This lesson we're going to learn about mole volume conversions and gas densities. So far we have learned to convert between moles and particles using Avogadro's number as equivalent. We've learned to convert between moles and mass using the molar mass as equivalent between 1 mole and molar mass. This time we're going to learn to convert between moles and liters, moles and volume, using the equivalent 1 mole equals 22.4 liters. When you're going from liters to moles, you're going to divide by the 22.4, and when you're going from moles to liters, you're going to multiply by the 22.4 liters per mole. So if I asked you, what is the volume of 2.50 moles of hydrogen gas at STP? Again, you need to know the equivalent is 1 mole is 22.4 liters at STP, where STP stands for standard temperature and pressure. Standard temperature is 0 degrees Celsius. Standard pressure is 1 atmosphere pressure. Because gases change quite drastically with changes in temperature, changes in pressure, we must have a standard set of conditions to compare different gases to. And so again, dimensional analysis, you take your known, the 2.50 moles, you set it up with a pair of parentheses as such, and then the unit you're converting from is going to go on bottom. The unit you're converting into goes on top. This way moles and moles are going to cancel, and that will give you the volume in liters. Going the other way around, if I asked you how many moles of helium will be needed to fill a 2,000 liter balloon at standard temperature and pressure, again, same equivalent, but now we're going from volume to moles or liters to moles. Now we want the 22.4 liters on bottom, so we'll divide by the 22.4, the 1 mole on top. Again, liters and liters will now cancel, so now I have to divide by the 22.4 liters to get the number of moles. This frame is to get you thinking about the relationship between molar mass and volume and the number of moles. So if I had 3 gases, gas A, gas B, gas C, and they're all at STP, and they all have a volume of 22.4 liters, and I ask you what is the molar mass, the answer is it's 44 grams for mole A because there's 22.4 liters. At STP, that is 1 mole, and 1 mole has a molar mass of 44. For gas B, it's 32. For gas C, it is 70.90. And if I asked you which gas might be oxygen, the answer is going to be gas B because gas B has a molar mass of 32 and oxygen has a molar mass of 32. Now let's look at gas D. Okay, now I've only given you 11.2 liters and it has a molar mass of 32. And now think about this. 11.2 is half of 22.4, so if half of a mole has a mass of 32, then 1 mole is going to be 64.00 grams of gas, and that will be the molar mass of that. Now we look at gas E. Now we have a volume of 1 liter and a mass of 2, and again there's 22.4 liters per mole, and this really is the density. The density is how many grams per liter. So this is 2.00 grams per liter. If we multiply that by 22.4, that'll give us the molar mass of gas E. So again, we see a relation between mass, volume, density, and the number of moles. And so if I asked you what is the density of oxygen gas, we just need to take the mass divided by the volume. So the mass of 1 mole is 32. The volume of 1 mole is 22.4. Give us a density of 1.4 grams per liter. So we can go from the molar mass to density, and we can also go from the density back to the molar mass. So here's a sample problem all worked out. What is the density of carbon dioxide gas at STP? Density, we need a mass, we need a volume, so we're just going to choose 1 mole. So 1 mole of carbon dioxide has a mass of 44. 1 mole has a volume of 22.4 liters, and so we just have to take the mass of 1 mole divided by the volume of 1 mole, and that gives us the density of carbon dioxide gas, again at STP. If I asked you what is the gram molecular mass of a gas which has a density of 1.786 grams per liter, we're really just going the opposite direction. Here I gave you the molar mass and asked you to figure out the density. Now I'm giving you the density, asking you to figure out the molar mass. And so again, we need to remember that 1 mole has a density, or 1 mole has a volume of 22.4 liters. And so if I take the density, multiply it by the ratio of 22.4 liters per mole, I will get grams per mole, which is the molar mass. And so that gas is going to have a molar mass of 40.0 grams per mole. We can carry this one step further. In analytical chemistry, we wish to identify unknowns. Mass and volume are things that can be easily measured in the laboratory. So say a laboratory collects a gas and they measure its mass and volume and finds its density to be 0.0902 grams per liter. And then they're determined, is this gas hydrogen gas, fluorine gas, chlorine, oxygen, or nitrogen gas? Again, take the density, multiply it by the number of liters per mole, gives you the molar mass of 2.02 grams per mole. And that has to be hydrogen because hydrogen is the only one that has the molar mass of 2.02 grams per mole.